Hi, today we're going to be doing Introduction to KiCad Lesson 1 and we're going to start with the schematic capture. The circuit I've chosen to look at today is a big Muff fuzz pedal from the 1970s. It's a very famous circuit. It's been cloned 1,000,001 times already, so of course the world needs another version. And specifically I'm going to be looking at the Pharaoh modification because that's the one I use on my pedal board. So we're going to jump right into the schematic capture. First step with KiCad open is to start a new project. And we're just going to give this a new folder. I'm going to call it Pharaoh, let's call it Muff, just to avoid any potential trademark infractions. I'm going to be working from this schematic here, but what I also like to do is generally I have a printed copy. It doesn't matter too much on this one because it's quite a small circuit, but when I'm working on a much bigger circuit, the different stuff, what I do is highlight the circuit as I go along, and that way I can see what I've done and which bits I haven't. It's just a great practice to get into if you're copying a large schematic. Have it on paper and mark it off in pen as you go along, and it'll save you a headache down the line. Okay, so first of all we're going to open up the schematic Eschema, and this brings you to a blank page. And if you haven't already installed libraries, I do cover that in my previous video. It's well worth a watch if you don't know how to manage your libraries. Getting on top of that will really help you down the line. So I'll link to that now, and watch that if you're not sure or you don't have any libraries installed. So first of all, what we're going to do is if you press A, it will bring up Add Component. The first thing I'm going to add, which is kind of on the schematic, but I have my own way of doing it. I have a supply pin, which is Board Quick Connect. Now this has my audio in, power in, ground and audio out, just on one handy little header. Pretty much all my boards use this connection, and it just saves a lot of time when you're actually assembling the board. And this gives us a chance to try out labels. So global labels are great because as long as you give them the same name, they'll join together. So if you're doing a large microcontroller or something and it's getting a bit difficult to actually physically route traces, what you can do is just label a pin ground and it'll connect it to ground as long as you name them exactly the same. It's like coding. If you put in a capital, it won't connect them together. And yes, I've done that and cocked up PCBs because I didn't pay attention to capitals. So let's just call this, I won't do ground, I'll do plus 9 volts. This will be a 9 volt effect, 9 volt positive, so plus 9 volt. And I'll connect that to the 9 volt header on my board. Now anything I also label as plus 9 volt will connect to this point anyway, so I don't have to physically route a wire to it. If you want to copy any component at all, you just hover over it and press C and it will give you a copy, and if you hover over it and press R, it will rotate the part. You can also highlight and drag multiple components to move them around. You can press W. W is the shortcut for wire, so if you're hovering over a pin, it'll connect it to that pin. The next label I'll add will be ground, but I'll use these symbols here. Ground symbol. So anything labelled with that will all join together as well. Quite a bit out of it. So here I'll call this out. And the reason I do this way is my in and outs my circuit will end up kind of here and here. So it just looks messy if you end up running traces, running wires right across the schematic. It's just so much neater to have it this way. Copy, and I can just edit that. If you hover over a part and press E, it brings up the edit page. That's the header for the input of the circuit. And now we'll worry about the actual schematic. So we've got the input comes in here. And the first thing we have is R1 resistor 2M to ground. So we'll copy our in, hover over and press C. And it brings up that label and we can rotate it round. And then if we press A again, it'll bring up our list of components. And we can go down to resistor. I've actually got two resistor libraries. This one is the stock one. I tend to use resistor, which is my own one, which I know which footprints they're tied to, so it's just a bit quicker. And I'm probably going to do this entire board, all the resistors at least, SMD. So I'm going to use that one because I'm pretty sure that is linked to an SMD part. Right, and if we look, that goes to ground, so I'm not going to put it there. I'm going to get there. Now, you can put all your parts in and then label them up with values. I prefer to at least try and do them as I go. I'll probably miss some of them. But it saves you the long boring job of going around afterwards and just writing on the component values, and also helps you navigate. Again, if you've got quite a big circuit, knowing which part's what early helps you navigate around what you're doing. So the very next component we have in the schematic is this switch. So again, we'll add and we'll go to switches. So the first thing we have is this single pole double throw. So single pole double throw switch. And I'll connect that up. I will call this high-low. And connected to that we've got two more resistors, so again I can just copy that part and you can move these values around if you just hover over them and press M. Lets you move the and sometimes if you've hovered over something and it's got two things overlapping, again if you press move it should say clarify, and you want the field reference to move in this case. So all these parts, they snap to a grid. I tend to just go to 25 grid, and then you can position things much closer to where you want them. Some parts as well will be on a 25 grid, so they'll be very difficult, if not impossible, to connect up all the pins to if you're not set to the correct grid for the part. Okay, so these join together. And the next part in here is this electrolytic capacitor. If we had electrolytic capacitors, and that is 10U, which in my library, most of these I've assigned footprints to already, stock footprints. If you press Control E over a part, it brings up the page to edit the schematic symbol, and here you've got this grey text. This grey text sets what footprint this part is associated with. So if you hover over the grey text again and press E, edit field footprint, you can now select footprints. On it. It does have the 3D viewer, but probably I haven't assigned a 3D model to most of these because I don't use most of them. This one I'm pretty sure I do use, so if I go 3D viewer, we have a 3D model of the part. So that looks correct to me. It doesn't. The 3D model doesn't matter apart from when you want to do your 3D view of your board before you have it made. It can just be nice to look at, useful to see if things will conflict. But this doesn't actually save this part permanently attached to this. This is just what it defaults to. So later, once we've done the schematic, I'll show you how to assign footprints for each PCB. But if you've set the default one to the one you're most likely to use, it will save so much time down the road. Really will save hours of time if you end up doing a lot of boards. Hover over the component and press R. Press M to move it. And then we've got another resist. Oh, I forgot to change these. See, this is always get changed, so that should be 39k. And this one should be 390k. So don't worry about part numbers. You'll assign all of these later when you do annotations. Okay, so I'll probably end up speeding up bits of this because you don't need to see me putting in 300 of the same parts. And I'll try and just stop and explain things if I'm doing anything differently at any point. We'll see how far I get in 20 minutes or so. Collector base emitter. So you can see here, this is if you've got a big schematic, sometimes that is the key to your PCB working or not working. I've had enough of them. One tiny little gap. And then this is connected straight to 9 volts, so let's stick that there. So it's now starting to look like it might do something. 0.47U is 470N. So and then here we've got our first potentiometer. So this is the distortion control. It's often labelled saturation on other big Muff clones, and I think the original calls it saturation. So what controls have we actually got here? We've got distortion, tone, high, and volume are the main controls. You also got this switch here, and of course the input switch. But what I might do before I go to PCB is just look at what other switchable mods there are, because there are so many for this circuit, and it'd be a shame to, you know, miss out on the ability to put some mods in there. So for potentiometers, now that's annoying, it split them in half for some reason. And it's a little messy, but what I've started doing with pots, because the silkscreen values that get updated on the PCB, I haven't found a way. I've got this version here. I go potentiometers, pot value, this. So I added in an extra field, name, so I could give it the name of the control, like gain, distortion, volume. But this name wasn't getting updated on the silk screen. I have no idea how to make that work. If someone knows how to do that, if you could explain in the comments, that would be great. I would love you for that. It didn't seem to update itself on the PCB, so I gave up with that, and instead of variable resistor as a value, I've just started putting in here distortion. It puts a number after it, and because it's a unique name, you'll end up with distortion 1, tone 1, volume 1. It's not as neat as I'd like it, but it does make things easier. So that's a 1K that goes direct to ground, so I can just highlight that whole thing. Control copy, Control V. Right, move everything over because you'll start running out of space quite quickly. And you can, it's quite a small circuit, so I shouldn't think I'll have to, but page settings, you can set a bigger page size if you're running out of room on there for whatever you're laying out. Often what I'll do if I'm starting to reach the end is just make wires shorter and squash everything in, but it's nice to keep it nice and wide for as long as you can. If you don't have to squash it all in together, it does make it easier to read. Let's just squeeze it up there. So then we've got a 47N capacitor there. So that's a 6K2. So that's got us up to here. So this whole section up to distortion is the first gain stage. So what I'm going to do is, you've got this graphic lines, and I can label this. And if you press Shift T, it brings up the text box, and you can type text and annotate your schematic. So I'll call this first gain stage. First gain stage. It doesn't really matter, it just lets us easily see which bits of the circuit's doing what. Could be interesting when we come to modify it later. Got to fit 4 of these bad boys on there. So the next stage, if you look, is very, very similar to the first stage. We have a transistor, so we've got input through a cap and a resistor, which we've then got 100k to ground, same as that. The value's different, but that part's there. That's... So what I can do is 10k there, so I'm going to highlight all of that. Control copy, Control V. So that goes there. If you've got a nice fat dot, you know that's nicely connected. 470, 470, that's all correct. 100k to ground. That goes directly to the base. And then the difference is this here is 100R, sorry, rather than 1k, so 100R. I tend to specify R for ohms rather than just 100, because again it just becomes a bit ambiguous when it's on a PCB. If you put R, then it's quite clearly 100R resistance. Again, just keeps things nice and neat. You've got to think about how things will print on the silk screen. It's not a great print you get, so the clearer you can make your labels at this stage, the better it will come out on your silk screen of the PCB. So here, the major difference between the first gain stage and the second gain stage is this has this these diodes in the feedback loop. So these will change the nature of how it clips. They actually clip a little earlier than the transistor will, and they clip a bit softer, so you end up with a rounder waveform with these. So you get a very square wave out of the transistor without them, and you'll get a slightly rounder wave with them in. So it's slightly less odd order harmonics, and a slightly smoother sound. Potentially. So 1N914s I believe are just silicon diodes. I wonder what my so in one of my folders I've got the the one I built on tag board. It'd be interesting to see actually what diodes I ended up using in it. But I think it'll be in a different folder, so I might just check that in my own time. So that's good, and then on the output of this, the collector, we've got 47NF, so smaller again. So really, with this cap is kind of the end of our second gain stage here. Count that as the DC blocking cap for this transistor, so I'm going to label that all as the second gain stage. Can change the size of this text here, orientations, but that looks fine to me for now. I think I'm going to leave this here tonight. So next time we'll finish the rest of this schematic off. I mean, you pretty much get how this works now anyway. By the end of the next episode we'll finish this off. We'll go through annotations, we'll do an electrical rules check. We'll then run through the CVP PCB, which will assign our footprints, and we'll generate a netlist, and then the episode after that we can go straight into PCBnew and start arranging our components on the PCB. So thank you very much for watching.